I can see you on the screen. So Brendan is our president. He's gonna sort of be in the background doing nothing but teaching a class. Dave Stetz is a member of the board of ProRate Energy, and he's here. I don't know, no one else wants to show their face, but he's past president of Louisiana Sierra Club. Richard Smith had a roofing company called Snow White Roofers because he was very committed to making roofs white to make the energy bills lower. And Erica is a architect, and she has yet to talk to us or show her face.
Oh, hello. I have my family in the background, so I'm probably gonna be on mute most of the time, but
Are they going to be listening to?
let's see. Hi.
Hi there. So, okay. So I spent a lot of time making this PowerPoint, and I don't know when you make a PowerPoint, I'll either go too fast or too slow. So slow me down or speed me up if you think so. It's 27 slides. It's mostly pictures. And so the original document it came from was 14 pages long. So it really shouldn't be not be more than about 15 minutes to get through, but I have too much to say. So we also might have some very interesting guests. A woman named Anu, I met walking in the park literally yesterday, and she sounded very interested. So she might show up. We'll see. So without further ado, I'm going to start the slideshow. First of all, I'm going to share my screen. I'm going to share the second screen. And then I'm going to go to my place where the PowerPoint presentation is stored in my computer, which is right here. And I'll start it up. Okay. And so I'll hit F5. That should start right up. Okay. The name of the talk, and I'll remind everyone, I asked everyone to watch some background data, and I said we'd be talking about the 3 kinds of resilience important to New Orleans. And it turns out when I got into actually preparing this talk, I realized reliability needs to be discussed independently and in conjunction with resilience to explain what's going on and why it is that the Make It Right homes failed. So I figured out that the right title is Adequate Reliability Resilience Can Be Built into Our Homes and Solve All 3 resilience problems while everyone is paid to help. So we'll go to the next slide. Let's see where the next slide button is. I don't know. Okay, that'll do. Okay, so I found 4 websites that basically say the same thing. Resilient construction means that it's built to withstand natural and man-made disasters. And this picture right here is an excerpt from a video, about a 4-minute video that you can actually link to. The link is over here. If you get the PowerPoint sent to you, which I'll do later, you can click it and watch the longer video. But the point is, they say if you live in a flood-prone place and you want to be resilient, build your house on something to raise you up over the flood, which most homes in New Orleans are raised up. And the home we're going to be looking at later is 2 or 3 feet off the ground on piers like an open crawl space. And that is good for resilience, but is it good for everything? So, so then we say, what is reliability and what are resilience? This particular quote from the Oxford Dictionary was provided by PJM's website. So you may not know who PJM is. PJM is Pennsylvania, Jersey, Maryland Wholesale Marketplace, which is the oldest and largest wholesale marketplace in the country. It handles those 2 in about 500 or 600 states, going all the way to Chicago. And since they're in the wholesale business, they're interested in getting electricity to people. And so from the point of view of energy, they say reliability is the ability to meet the electricity needs of end-use customers, comma, even when unexpected equipment failures or other conditions reduce the availability of power supply. I find this particular definition confusing because it seems to mix the 2 meanings of reliability and resilience together. Until you get to the comma, you're talking about reliability, and after the comma, you're talking about resilience. And so as a way of explaining reliability and resilience, they confuse you. But apparently that's not uncommon for utilities. And so we'll see how you get resilience despite the fact that the utility is not helping you. But part of the problem is that the way they do things they consider utility reliability from the point of view of the supplier and not from the point of view of the consumer. And we're going to be showing how that changes how to solve the problem in a bad way. Okay, so I get this out of here. I don't know. There's something from Zoom getting in the way of doing the slideshow, so I'll forget at that. All right, so the next thing is, what is resilience and what does it protect you against? So in the last 44 years, there has been over $2.7 trillion of damage from disasters. Obviously, earlier in 1945 and 1950, it was very infrequent, but the frequency grew to as much as 239 per year by around 1980 and over 400 per year around 2015. So the frequency is raising and the amount of billions of dollars lost increases. And so it's really worth it to build a home to avoid resilience. In the article referenced here, it says that actually it costs about 10% more to make a resilient home, but you get 6 times your money back for the amount of damage you avoid by making a home more resilient. So it's definitely something we should want to do. Okay. And the link to the website here is available, as I say, when you get the PowerPoint, you'll find all the links. I'm not going to load us down by talking about links. Okay. So let's see, back to this. All right. So in order to understand reliability and resilience, we need to talk about the features of a home that offer either. So let's do resilience first because that's closer to the title of the talk and what we decided to come here for. So what provides resilience? Piers that raise the home above flood level, like the picture we saw in the second slide. Hurricane shutters and windows protect against wind. Metal roofs work better against wind. Operable windows allow cooling when the electricity is not available. And of course, having energy and power are very important to get you through in case there is a storm. So a battery is really useful if you have renewable energy systems. What about reliability? Reliability is about 10 bullets on this. The first 5 are in this slide. Enclosing your crawl space helps protect the floors above from rotting and provides beneficial heat flows year-round. Radiant barriers slow down the heat gain in the attic. Closed shutters lower cooling bills. Operable windows allow cooling when AC is not needed, and they provide excellent ways to manage moisture flows, help durability. 2 more reliability features. Multiple ventilation methods also improve indoor air quality and efficient lighting, cooling, and water heating, lower carbon footprint. But the last one on the list is both reliability and resilience, namely Wi-Fi controllable water heater and air cooling systems provide load flexibility. And if you don't know what that is, raise your hand, ask me up, disturb me, and I'll explain it. Savings or income when time-dependent electricity pricing is implemented. And we can use that money to buy batteries that we may not have purchased at first. Am I going too fast or too slow? Somebody tell me something. Okay, so this is one of the pictures from the Make It Right video that I asked you to watch, only 10 minutes out of that video. So did Make It Right build resilient homes? Well, this home looks like a resilient home. It's on piers, right? It looks like it's got a nice roof, nice windows, maybe there are shutters there. Looks very resilient. Okay, however, this is a guy who bought virtually the same home, and Spike Lee is talking to this guy's name, Ellie Ivory, and he says, you mean your leg went through the floor? Yes, my leg went through the floor. And there it is, the hole in the floor right in front of his toilet that rotted out, the wood rotted out. So yes, they built a resilient home, but they skipped lots of things about reliability. So you might think you get reliability if you do resilient, but not necessarily. So the Make It Right project leaders mistakenly believed that resilient measures would ensure reliability, leading to a critical design flaw in home construction. What did they forget to do? They didn't realize that flood protection does not stop persistent wood or wood rot from constant wetting, especially with prolonged indoor cooling below the outdoor dew point. I think most of the people in this group know what those words mean, but if you need to interrupt me, please interrupt me. Okay, so if you enclose the crawl space, you improve your durability because there is a comprehensive way to protect the floors from that moisture flow. And while you're doing it, you'll have beneficial heat flows. And if you don't know why that is, I encourage you to ask me. So this is the home that was highlighted in the webpage I told you to go to where I was renting this house. And I recently actually got a tenant. I'm so happy. But I had made a nice presentation on the webpage, but this is one of the views from the webpage. And you can see the house has a white roof. But more importantly, the crawl space is all closed. All those openings between the piers. Over here, you can see a brick pier, another brick pier, etc. But over here is closed up. I think this is hardy panel. In most cases, this is a wooden opening here, which I'm going to open in the next picture and show you what it looks like in the crawl space. So I opened the crawl space literally 2 weeks ago. It was the first time I did it in over half a decade, half a year. And much to my dismay, there was a standing water of around 10 to 15 square feet all over the plastic cover over the floor. And I said, oh my gosh, maybe this crawl space is failing. But when I checked out the wood was all dry. And when I checked out the temperature of the air and the humidity, I found out it was dry. The crawl space had a dew point of 60 degrees Fahrenheit. I have this little app on my phone which allow me to do a test like this, no matter where I am. And I ran the app for about three, three, 3 or 4 minutes, and I saw the thing meandering and start to settle down around the current temperature and relative humidity. And if you do the calculation, those two numbers give you all you need to know about dew point. Maybe you don't know what dew point means. A simple example is take a bottle of water, pour all the water out, and close the top, put it in the freezer, and you'll see water accumulates in the freezer and refreezes. That means there was water in the air. The water comes out when the temperature drops. And when it first starts to drop out, that's the dew point of the air. So if the air in the house, in the air below the house is colder than the air in the house, the moisture will be deposited on the floor and can rot the floor if the floor is made out of the wrong materials. Old houses have pine floors or cypress floors, very thick. They could tolerate a lot of moisture flows. But when this house was new in 1880, there was no air conditioning, there was no driving moisture flow. But modern homes have air conditioning, you got to take care of the moisture flow. And they didn't do that and make it right. So the outside dew point is way higher. So if you close the crawl space, you keep this outside air away from the floor. If you don't close the crawl space, this moisture is going to come get you. Okay, so what else did we do in this house? Well, I used super effective insulation. So this is the floor of the attic when I walked in, literally on Sunday, to take these pictures for the slideshow. And you can see there's insulation on the floor of the attic. This happened to be blown in cellulose and plastic covering it. And so I wanted to show you that what I described, I told the workers to do this. I said, put a layer of plastic down and then insulation and then plastic and then insulation and then plastic. And that's how the layer I wanted it installed. And I already had a study that I published on my website, which I'll show you a link to, where this improves the R value insulation by a factor of 30. So the next picture shows you the insulation. So I actually pulled away some of the plastic, and then I pulled away about 10 square inches of cellulose off the floor down to the second layer of plastic. And you can see there's a second layer of plastic here under the first layer and insulation below that. So this is a triple decker, as I promised. That's what it is. And that's exactly what there is in this attic. And that's why the insulation works so well. So the next thing I talk about is the attic itself. How well is it keeping cool? So first of all, it's cool because it's got a white roof. Secondly, it's cool because there's a radiant barrier below the rafters. Okay. Those two together, I did a temperature test literally yesterday. At 1 p.m., I'd measured the temperature in the attic. It was about 86 degrees, which is about the same temperature it was outside at that time, which means the attic is seldom getting hotter than outside, which is what I assert in the title of this paper, on this slide. Now I'm talking about the windows. The windows are very important. As I mentioned, in resilience, closing the shutters and closing the windows are very important to resilience. But it's also important to be able to operate them. I took all these pictures while I was holding the cell phone in my right hand and opening the windows with my left hand. I forgot which hand I used, but you'll see in a minute. So you open the windows, a simple double hung window. Double hung windows are good. They work very, very well. They're not worth replacing if you can get them to work properly, the way they were originally designed. And what I did is I added a screen between the outer stop of the window sashes and the inner stop of the shutter, which most people have never seen that before. I'm not surprised because I invented it. And I show you that the screen is operable. So if you open the window, You get to the bottom of the screen, you can see a flap here. If you raise the flap, that's what I mean by operable, and you put up against the stop on the left so that you have access under the screen, stick your hand through here and open up the two shutter latches and push the shutters out, and you've got windows open, the shutters stay open. Okay, they stay open because the way shutters operate is they stay open. This latch right here keeps them stationary when they're down. But if you want to close them, you stick your hand in. Obviously, I was holding the camera with my right hand because you can see my left hand is operating the shutters. I'm operating the left shutter in this picture, and I pull it, it's almost closed. In the second picture, I start operating the shutter on the right in the third picture, and now both shutters are closed. I close the shutter latches, lower the flap of the screen, and close the window. And now I've got complete access of shutters from the inside. And it's a big deal because if you live in a home where a hurricane's coming, you need to be able to operate the shutters without getting on a ladder. It's dangerous. And this also provides security against people who might be a criminal. You can leave the windows open with the shutters closed and no one can tell the windows open. So you have the opportunity of ventilation, even though you might live in a neighborhood that's not too safe. You can also force exfiltration, namely ventilation, where you're taking air from outside and passing it through your house and exhausting it. And you can do that to protect the walls of your bathroom. So how do you do that? Well, you have a light switch like this, a fan switch, but it actually has let's see, 6 different time intervals that are run. The top one is on continuously. The lowest one is on for 5 minutes. So what you would do is if you're at a time of the year when you don't need heating and cooling, like maybe the next 2 or 3 months, and similarly in the spring, you can turn on this exhaust fan and using the bathroom exhaust device to go out, take the air out of the house, and the adjacent window of your bedroom, you can bring cool, fresh air into your house and exhaust it out the bathroom and do this continuously for months if you want to in those off-season non-cooling years. But in the case where it is cooling time or heating time, you want to ventilate very little air because that's conditioned air. And so you might run it for 5 minutes if you use a toilet or 15 or 20 minutes if you use a shower. And you really need to do it because this house was damaged by the previous tenant who didn't use that fan and overwetted the inside of the bathroom. So what about lighting? Well, lighting in this house has multiple features. This light right here was just a construction light, but the fan eventually was put in the same kind of LED dimmable lights. These are dimmable, these are dimmable, these are dimmable. This is the master bathroom. This is the kitchen, as you can guess. And these are all workstation lights over the work area, each with a separate switch. Lighting is very important. That's in the right place and the right intensity. And because of this lighting is so well organized, it has a negligible effect on your energy bill, unlike the way lighting used to be. It used to be about 10% of your cooling load was caused by your lighting. Now, this is the feature of the home that I said before, is the one feature that's both in the reliability list and the resilience list. How is that? Well, both of these create thermal batteries where you can heat your water in the morning with the cheapest electricity and use the hot water later, and that's the thermal battery. Similarly, you can do the same thing with your air conditioner. This particular apartment has 4 inside units. You can stagger the use so they don't cool at the same time, so you don't get a high demand at any moment. So there may be only 2 of these units be operating at a time if they're offset by 10 minutes. Or they could be controlled remotely by the utility or an aggregator. Both of these things can be aggregated or controlled that way. And that allows you to load flex your appliances. Your biggest energy uses of your apartment are clearly your water heater and air conditioner, and they can be controlled remotely. And if with the right time of use rate design, which we'll talk about in a minute, you can have big savings. In fact, we did a calculation using 2018 electricity prices. We found that just using your water heater this way saves $185 a year in water heating costs. Air conditioning costs would be much higher, but we didn't calculate that for whatever reason. So now I want to get to the part about the grid. As I explained, we're going to solve the problem of the grid by doing something in your home. How do we do that? Well, so if we go back to the third slide where PJM talked about reliability and resilience, and they were interested in providing resilience despite the fact that the transmission lines might go down or the generators might go down, and they call that resilience and reliability in a mixed up way, but nevertheless, that were dependent upon the assertion that the grid was all from top down view, namely the electricity comes from the central generators and central transmission lines through the distribution system to the grid edge where you and I live. Okay. However, that's not what they did here. This particular picture is a picture of a microgrid put on a building in probably the most impoverished country in the world called Malawi. This is a quote from an email from one of the members of the Electricity Brain Trust from September 9th. Many African villages are entirely skipping the grid phase of electrification by moving directly to solar battery systems which don't rely on expensive and vulnerable transmission lines. This photo is from a school in Malawi, one of the poorest nations in the world, where the per capita GDP is $508 US. So we can do the same thing on our homes, but the extra cost of the solar and batteries, where is it going to come from? And that's what we talk about in the next slide. So where do we get that money? The answer is ProRate. That's the rate design that most people who are regulars in this meeting know a lot about. And those who are coming in for the first time maybe have to learn on, but I give you links to help you learn. So we can get all the capital we need for those batteries and solar from the wasted hundreds of millions of dollars every year by the utility who has no incentive to buy electricity when the price is cheap. And if we so do it, it can then pass that savings to the end users. Okay, so more about that. And this is the last slide in the whole deck. So how do we profit by making our homes more reliable and resilient? How does that help protect our city from climate change? So if you go to this website, and believe me, explaining this is a whole hour on its own. So I encourage you to do it. But it explains our rate design, which includes a bidirectional electricity rate design that changes prices every 5 minutes, consistent with the wholesale marketplace. And the lowest price is like 2 or 3 cents, and the highest price is 10 to 100 cents in a 5-minute period. So if you can buy electricity when it's cheap and sell it back when it's expensive, you could easily pay for any size battery you want. And if you don't like the explanation there, it's also on my website, Building Science Innovators. But the last sentence in the Building Science Innovators website, and I'll read it to you. Oops, I jumped out. I got to get back to where I was. Let's see. Get back to the slideshow over here, and then go to the last slide in the slideshow. Got to be careful not to get past the last slide, which is what I just accidentally did. But if you're here, and then I go to the reference to I'm looking at my speaker's notes. It says that if ProRate was successful as expected, it can be promoted, scaled, and exported to all utilities of the world, and thereby have a big impact on slowing the causes of climate change. So this ProRate would have these big effects all over the world if it was tested successfully here. So it's not a surprise that promoting ProRate is a regular activity of these meetings. Okay, now I am finished talking, and I hope people ask questions because I don't know how fast I did that. I probably did it way faster than I needed to. Looks like I did it in 20 minutes, and I want people to ask questions. So somebody want to talk, please do.
Where'd the water come from under the house?
Okay, so let me go back to that slide and I'll explain it to you. Okay, so let me get to the place where it is back here. Okay, so if you look at this picture, you'll see these white pipes right here are the down pipes for the condensate of the air conditioners. In this particular crawl space, you're sitting underneath 8 of these inside units. Okay, and instead of putting them into these traps, which I could do, I actually put in more than enough traps. You can see one of the condensate line is going into a trap, and this one's going into a trap, but this one is not. And so this one is not. I could get them all to go into traps, and I was ambivalent about whether I should put them in traps or not. And I'm sort of glad I didn't. But that's where the water's coming from. It's coming from the condensate. So these air conditioners
Why are
probably
you glad? Why are you glad you didn't?
because I showed it wasn't needed. Namely, I showed that even if I didn't put in them into the traps, the crawl space could handle the moisture load, and it did. Okay, so I was glad I didn't. I also wish I had. I mean, it would have been drier. Okay, but nevertheless,
Oh, you're glad you didn't because it was an experiment?
yeah.
Because it's certainly not best practice.
I agree, but here's the thing. I actually tried putting condensate lines and traps in other homes, and I found that it also caused another kind of problem where the condensate line didn't drain enough and it clogged up, and then the air conditioner had problems. So I was kind of ambivalent about whether I really wanted to do it. So I set it up to do. By the way, this picture is taken at an angle, but you know which way horizontal is because you can see the drain line it has to be horizontal. So don't be confused by the way the floor looks like it's
It
hot,
has
right?
to be sloped.
Yeah,
The
it's
drain.
not sloped. Yeah, the
It-
drain line, it's got a tiny slope, but nowhere near the slope you see in this picture. So Dan is right. There's moisture here. Where'd it come from? It came from the condensate lines. And the way it's set up, this plastic is not watertight. Water is expected to get onto it and evaporate away. And even with this moisture flow, it still provided a relatively dry crawl space. So
But it can't be good for air quality in general.
it's not good if it's more moist, for sure, but it wasn't so moist. Look. Okay. So anyway, thanks for the question, Dan. I'm glad you were paying attention. Okay. All right.
So
Any,
when you say enclosing a crawl space, I think you should add the word properly before that, because you just
okay.
make it as a matter of fact that if you enclose your crawl space, you're doing something good. But a lot of times you can enclose it and cause all kinds of mayhem and
I
problems.
agree. I absolutely agree with that. In fact, had some trepidation when I opened that door to get in there. I didn't know I was going to see. Actually, I've spoken to many people who thought they knew better, installation contractors, and said you can get a big mold problem if you make it too tight, etc. I didn't make it too tight. I have other pictures, which are not in this group. Where you can look at the side, you can see tiny cracks around the door openings. So it wasn't too tight. But also the air conditioner itself is constantly drying the crawl space because the wood floor between the crawl space above and which separates the ceiling of the crawl space is the floor of the house. That's constantly being dried by the air conditioner. So
Especially when you got a puddle under there.
yeah, right. The puddle, I'm sure more moisture came through than came out for the puddle. But you're right. It'd be
Myron,
better. Yeah.
I've got a question. How do you avoid mold?
Okay. Well, you're not going to get mold if the dew point's low. Period.
Okay, I understand that.
But I didn't have any mold because the dew point is low. See, it's 60 degrees, which is easily 10 to 15 degrees lower than the temperature of the air conditioned floor. Okay.
Mm.
So some people cool at 75 degrees, some cool at 70 degrees. I'm not telling you what they have to do. I'm just saying it's drier than that. And not going to get any mold growth if the air is dry. Okay. And more importantly, not if the air is dry, but there's no moisture accumulating in the wood. And it's not accumulating, obviously it's passing through. It's one of the things that people don't realize is that you do want moisture to flow through a house. You don't want it to get accumulating. And that was an interesting question. I skipped over this, but it's real important to talk about. Let's go to the attic insulation. So it's the next picture. And the guy who discovered this experiment, this thing was a high school student. There's a long story about it. But he realized that when he first did the insulation without any plastic coating, he got a much lower R value than the insulated rated value when he bought it at the store. So he decided, let's put a cover on it. And sure enough, the R value increased by a factor of 10, not to 30, which is the actual rating of the insulation, but 10 times higher than what he got on his first test. So then he decided, well, maybe this might be trapping moisture in the plastic. So he did a subsequent test and found that the insulation was drier with the plastic over it than without the plastic over it. And we can argue all day long why it is, and we could be right or wrong about our arguments, but this is what the tests show. And this particular idea of membranes improve insulation efficiency is actually published on the AEEE website. They published exactly the same report. So it's a respected report, and I use it, and this is all bone dry material.
Myron, is the blown-in cellulose sort of your go-to insulation option for this condition?
You can use the blown-in cellulose, or you can use blown-in fiberglass, or you can use fiberglass bats. One of the problems with fiberglass bats is the spacing between the joists in this case may not be consistent or match what the fiberglass bat width is. So that makes it tougher to do, and you need to keep the labor costs down. And nothing is faster than blowing in insulation in terms of labor costs. But you can do any of those three, and the particular report I refer to, and I remind you, if you look in my website, Building Science Innovators, I might be able to put this on the screen. If we go to chat, maybe I can bring this in a chat button. Anybody knows how to go into chat? Let's see, where are we? Or is I over here? I need to get to where I was. Let's see.
You might mention there is some manufacturers do sell encapsulated insulation. They really encapsulate it so that the installer doesn't get itchy hands, but it is done properly. It's 1 mil on the outside. The inner layer is 0.5 mil. And if you put a second layer next to it of the 0.5 mil, you'll end up with 1 mil, 1 mil, and 1 mil with the sandwiching the insulation.
I just put the link to it, to what we're talking about in the chat, so you can pull it up there. But there's actually a published report. I got a copy of it, transcribed it because it was published in printed form, not an email, because this was 1986. But I transcribed it, and I can, if you look up that same name, you'll find it published on the AEEE website. So it's respected technology, but it's certainly unusual. Most people don't know about it. And if I'm not showing you something unusual, then I'm not satisfying my own need to be helpful. So, all right, so good. Please ask me some more questions. I'm delighted. Okay, let's see.
Did you hear me, Myron, earlier?
Yeah, I heard what you said, Dave, and I really appreciate it.
Okay. Okay. No, I wasn't sure that my thing was working.
I want to talk a little bit about why this phenomenon happens. Why is it
Yeah.
that insulation is all on the floor of the attic, according to the manufacturer's recommendations and according to the manufacturer's specification, this insulation should be working 30 times better than it does when it's installed on the floor of the attic. Why is that? It's because the way insulation is tested, it's tested in what's called a hot box test, where they put the insulation in an airtight container and they measure temperatures across it. They put one side hotter than the other side, they measure the heat flow, and from that they can get the R value. However, insulation when installed on the floor of the attic is not an airtight container. So air flows through it, the heat could be flowing with the air, which in fact it is. We know air flows through fiberglass or cellulose insulation because air conditioned filters are fiberglass insulation. So obviously fiberglass is not a barrier to airflows, and if it were, we couldn't use it as air conditioner. So how does fiberglass know when it's airflow barrier or an insulation? And the answer is it doesn't. And therefore air will flow through it, and when it does, the heat flows with the air, and the insulation isn't doing much. So this is why you would expect the R value to go up if you cover with plastic. But he didn't get it to go all the way up just with one cover. He needed the triple cover system to make it work. That's what his experiment shows. And if you go to his website, you'll see that. Okay. So, I'm delighted to answer questions. Thank you for the questions, Dave. And I mean, Dan, okay? And where's the moisture coming from in the crawl space and all that stuff? You're absolutely right. Crawl space specification maybe needs some improvement. I don't complain, but I do think this is way better than what we have. And I think a small improvement will be all it's needed for at least this house. So I don't know if people felt like I jumped to the end of the talk too fast. Let me go there and tell you what I'm talking about. Remember at the beginning of the talk, I said that we were going to go to solve all the resilience problems, or at least address all the resilience problems of New Orleans. And what are they? Well, among them is, are we going to be here as a result of climate change? Among them, are we going to have electricity that we need? And obviously, are we going to have resilient homes? And I say we can do that all in our homes. Why can we do it all in our homes? Well, we can build the resilient features into the homes like the ones I listed, and they're not all of them. I said those are the prominent resilience features. I'm sure Dan can tell me 2 or 3 I skipped. Okay, Dan's an architect, by the way. So is Erica. You guys should meet, okay? But I've listed the prominent ones, and the reliability issues are also not all, but I've listed the prominent ones. But when you get to the end of the talk, I'll go down to the end of the talk, and I'm trying to get to answer all the questions about utility resilience and home and the city's resilience again. Climate change, and this part of the talk. So first of all, we want to put microgrids, and everyone's in favor of microgrids. I don't care where you are, except for the utilities. Everyone likes microgrids. The utility likes microgrids that they own. They don't care for microgrids owned by the customers. But otherwise, everyone likes microgrids. The question is, how does this solve the problem? Well, you would think, well, you don't need the power lines. By the way, it's funny in the background, there's pictures of power lines. But anyway, so maybe the power lines are coming from this microgrid servicing nearby homes. I don't know how that works. The fact is, if we had at the grid edge, most homes where it's on microgrid, that would solve the reliability resilience problem of the homes and probably also for the neighbors and lower the cost of electricity and make it more reliable. But because we're not in that condition, we're not where Malawi is now, we have this whole grid system set up. We have these transmission lines and distribution lines and generators already set up and utilities already here. But they're doing a good job of wasting our money to the tune of hundreds of millions of dollars a year because they don't care buying electricity when it's cheaper. So why not use the utility to solve a problem they have to cause and use the energy flows? And I know there's probably no one in this group more in favor of time of use rate designs than Dan because he talks about it all the time. If we have a time of use rate design, the price changes, it doesn't even have to be bidirectional pricing, which is what ProRate has, to have a big effect in making batteries cost effective. So yes, we can, because this technique will get us to something we can export to utilities around the world and thereby have a big impact on climate change. I've said this twice now because I think it's important, because I said it too fast the first time. Okay, now, if nobody wants to ask questions, I'm happy to stop the slideshow and we can have a general conversation between us because I think maybe we don't know each other as well as we might. So I'm gonna.
I do have one more question, Myron.
What's that?
Going back to the Make It Right houses, I'm curious about some of the specific material choices and details that might have caused those failures and reliability that you shared.
Well, it turns out if you watch the video, and not mine, obviously this is not a video, but if you watch the video at about 2/3 of the way to the end of that 10-minute segment, they say we used a special wood which has no chemicals in it, blah, blah, blah.
I
for the
did
floor.
see that. What was that?
I don't know what it was, but the bottom line is if it's not made out of something like cypress or longleaf pine or some material that can handle moisture flows, it's not going to handle it. It's gonna rot. And the other problem with floors is that the U.S. flooring industry, and that's not the name, but I'm going to call it that generically, their name. They have a problem with warped floors. So what they tell people to do is they put a plastic layer over the subfloor so that the floor that you can see doesn't see the moisture flow coming from the crawl space. And that's a specification, and it's almost a requirement. If you don't do that, you won't get a warranty from the flooring company. The trouble is that'll trap the moisture flow. So any home that I work on, I'd say get rid of that. You do not want a plastic layer between the subfloor and the top floor. You don't want to trap moisture in the subfloor. That could very well have been what caused the floor to fail. But I don't know. I wasn't there in building the house.
Thank you.
Did you reference the Musicians Village study that LSU Ag did?
No, I didn't.
When their floors buckled?
Tell us about it.
Well, again, also after Katrina, Habitat for Humanity built the Musicians Village. And it was, I don't know, maybe a dozen homes, maybe more.
25.
And, how many?
25.
Awesome. And soon after they were being occupied, the floors started buckling. And they weren't old heart pine. They were, it was new construction. It was some sort of wafer board or plywood decking.
Right.
And then some sort of resilient click tile that they put down.
Right.
Anyway, they realized that the insulation that they put in between the joists was filled with gaps and created a whole moisture flow issue into the floorboards. And so they reached out to LSU Ag and they did a really thorough study on the conditions and had a number of recommendations for how to properly deal with crawl space and ventilation and insulation. or no insulation.
Right. I wouldn't be surprised.
Oh, you haven't read the study?
Yes, I
Well,
have not read the study.
I will send it to you.
Okay.
Or should I send it to the group or just you and you can
No,
decide?
send it to the group. It's a great idea. And by the way, in case you haven't noticed, I subscribed everyone to both forums, ProRate Energy at Google Groups and ProRate Discussion at Google Groups. And you're encouraged to use the ProRate Discussion for this process, not ProRate Energy. In fact, I've turned off your ability to post to ProRate Energy because we have over 100 people subscribed, including some members of the legislature and members of the city council and their aides. And if we give them too much stuff, they're going to stop participating at all. They won't want to read any of it. So we made the extra discussion forum for the purposes of these discussions without inundating others who don't want to see that much detail. So yes, ProRate Discussion for sending that, Dan. Everyone in this meeting is on that list.
Got it. Will do.
Okay. And I will be glad to send, if you want me to send the PowerPoint or the document from which the PowerPoint is derived. You'll get more of the references. Okay.
That'd be great.
So I didn't mean to go so fast that we would have nothing to talk about at the end. So Erica, why don't you introduce yourselves to us? I didn't do it before because I was afraid I'd run out of time. And then Dan and the rest can go around saying who they are.
Let me turn on my video if I can here. My toddler is gone for the moment, but Dan, we've actually crossed paths before a very long time ago. And we should definitely touch base again and reconnect.
For sure.
But I went to Tulane and I graduated back in 2009. And I'm just now coming back to the city, having worked up in New York for about 15 years. And my husband and I just bought a house over by Napoleon and Camp. And it's a very interesting house because the front section is, the original shotgun, and then they did a camelback edition that we would have done very differently now that we're here and seeing all the things that were not done right. And that's kind of what brought me to Myron, because I'm just trying to, all my husband and I seem to talk about right now is building science. And we were just looking for people to nerd out with about building science, because we want to get to the bottom of some of the things that aren't working as well as they could be in our house and try to fix them. And we're very, we love doing things ourselves. We actually just built a tiny house. The only part of it that we didn't build was the actual steel trailer. But every other screw, was us. And we're very proud of that. And we've come across a lot of really interesting problems, where we had designed, my husband had spent a lot of time designing the roof system, and he had like a small 1/2-inch vented space. And then below that, foil face polyiso and then rock wool. And around the foil face polyiso, we had done a little strip of spray foam. But it turned out on a super hot day that little tiny bits of air were leaking in areas where, the spray foam gun had kind of jumped and left like, a 1/16 inch gap. And we were actually getting condensation on the studs. And we discovered this right after having introduced air conditioning to the tiny house for the first time. We were worried about leaving it for a long period without any air conditioning, but then we introduced this temperature differential that was causing new problems. I don't know. We're very much in this building science world and just very excited to talk about this stuff and to figure out how to build better as architects.
That's awesome. It's
It
nice
is.
to have an experiment. What are you doing with the tiny home? Is it for like AUD or ADU?
It was originally a pandemic project. We were staying at his father's house in Maryland during the pandemic, trying to get out of the madness of New York. And we started this project and ended up essentially living in Maryland, building this thing for the past 4 years. And it's still not done. It's taking a
Is it-
very, very long time. So now
So
it's become a summer project because now we're living here and our daughter's in school. So summers
Yeah.
will be up in Maryland trying to finish this project.
Okay, so it's still up there.
It's still up there. I don't know what we'll do with it long term. It could come down here, or maybe it'll stay there. We're not sure.
Hurricane, a
Yeah.
hurricane evacuation spot.
Exactly.
Oh, that's cool. Well, welcome back.
Yeah, thank you.
I just want to say,
I just,
go ahead, Dan. I don't want to
I
cut you.
just celebrated 33 years with Wisnia.
You're still with Wisnia. That's amazing.
Yeah, I know, it's crazy. But yeah, yesterday was 33 years. So
Congratulations.
yeah, I got a brunch and a multi-tool. No more gold watches or gold pens or any of that anymore. It's just like a little bit of food and a multi-tool. So it's cool.
That's
But
perfect.
yeah, I mean, we moved our offices. We're formerly Lee Circle, now Harmony Circle. So we're in the K&B Plaza building on the same floor as Lee Ledbetter. So we kind of got a little thing going on with
Nice.
architects and design in that building. It's a beautiful building. If you've never been in it, the art collection's worth more than the building.
So let me let other people introduce themselves. So Dan, David, you spoke a little. Why don't you introduce yourself a bit more?
Okay, well, I'm Dave Stetz. Actually, now I'm a substitute teacher up in Virginia. But I've owned a solar company, and I built a modular home up here, and I incorporated most of the building science into it. It was I supervised it and did some of the work myself, but the idea we were going to, a general contractor and I were going to go into business, and then he died. So that never happened. But I'm trying to get my way back to New Orleans, but family problems have really prevented me from doing that. So, but one of these days I'll make it.
So Dave told me that what he was planning on doing at the house was he was going to build a under the ground area where he was going to store heat and use solar thermal panels and heat it up so he could heat his house with that. But that
Yeah, we did that with VCU 15 years ago.
Right.
If VCU had continued the work that we started, the company I was running funded the development work at VCU, and they actually coined the phrase. The grad student called it solar thermal energy storage, which is STETS without the last T. So it was named after me. Solar thermal energy storage is now the official title used around the world, but it heated the house that we built for 3 years, and then I moved out of it. So I still have the solar panels here, and I plan to put it in the basement of the house I built, but the contractors refused to dig the basement, so it has a crawl space, so I couldn't do it. So I intend to, if I build another house here or buy one, I'll have a basement so I can put the heat store back in.
Okay, Richard Jenkins, would you please introduce yourself and let Erica meet you?
We do that. Let's see if I can get myself on here. Well, I couldn't get the start video. I'm Richard Jenkins. My background in this kind of business was I was in showbiz for years, and when I got tired of living out of a suitcase, I came back to my father's construction business, which he said you will not like, and I did it for 30 years.
Right.
Did construction for 30 years. We were big residential, big church, commercial, did warehouses and the whole 9 yards. I managed at one point 2 buildings in downtown San Antonio, a 14-story majestic towers, and then the Brady building on top of the Aztec Theater in downtown San Antonio. Managed those properties right after the owner, who was a lawyer, a woman lawyer, who decided that she did not want to deal any longer with the assigned contractor for the project of remodeling her building. So she took it over, and she hired me to come in to find that her subs did the right thing after they finished the building. So I helped put in, estimate carpet to go into one of the largest libraries in the United States, which is here in San Antonio, Texas. And I have a full background in construction, but it all ends in 2000 when I now go into university teaching. And this is all a learning curve for me now to get stuff. I just got a roof bid 2 days ago. It was from a company that specializes using Pella windows, but they wanted to do a roof job because I could use a roof. And so for what they called a 3,600 square foot roof, they wanted to put down an OSB board, which I wasn't familiar with, to put the shingle on top of, better work. And they gave me a nice price for that of $156,000.
Wow.
And I was sitting there wondering, will I ever be able to sew my testicles back on after getting a bid like that? 156,000 and a $56,000 solar job without even saying anything about getting into the electrical boxes and running wire. So this is a nice learning curve for me. Thank God I've been in the business. I was hearing, like exposed subfloors. The way we used to handle exposed subfloors is we would take a BC plywood, normally 5/8 minimum, 3/4. We had a company here in San Antonio called Negley that did special paints, and we would seal the bottom of that plywood, exposed plywood, with that Negley paint, and I never had a problem with that. But we sealed it with paint, spray paint, and in many occasions I just did roller paint to make sure everything had a good thick coat on it. That's how we tried solving water problems and overcoming rot.
You're talking
and
about
so-
houses over open crawl space, right?
Yeah, open crawl space. Yeah.
Right.
We built big homes, up 14,000 square foot stuff. I mean, the wealthy stuff with velvet for all the silverware and all that lovely stuff. And my carpenters did most of the millwork, all of the framing. We even did foundation work.
What kind of coating did you use on that under coating? What was the product?
I'm sorry, say that again.
What was the product that you used to coat the face of the plywood?
We were using a Negley paint. I'm not sure if you can find Negley in Louisiana or nearby. It used to be very common, but 21 years in university teaching moved me away from the industry. I'm not even sure Negley, which really put out a first-class product, is even in business anymore.
Was it a waterborne system or oil-based?
It was water. It was
Waterborne.
waterborne.
Okay.
Yeah.
Okay.
Really sealed well. It was an excellent paint, made high standards.
How many mils you think it might have been on the average?
The mills depended
Approximately.
on your application system. If you're talking about mills of paint, technically, it was a thick paint. I could assume that possibly we were getting 3 mils
Wow.
with this very thick paint. It was one hell of a paint.
Must have been, yes.
And I never really got into the mill system. I did use a major painter here called Paramount Painting. He did a lot of federal work. And in federal work, government inspectors would come in with their various devices to see the mill
Right.
that was existing. And if it didn't make the requirement, guess what?
You'll lose.
Strip
Yeah.
it strip it all the way down
Correct.
and do it over.
Right.
And so I never got into that kind of business because I did not want to learn how to run a double, triple, quadruple bid to cover my butt if an
Understood.
inspector in federal situations came in and said, tear it out.
Understood.
Okay, I want to let other people talk. Alana, would you like to introduce yourself?
I would. Thank you, Myron. Hello everyone.
Hello.
My name is Ilana Stanger, and Ilana, my given name, is a Hebrew name that means tree, and Elana is how it's spelled in my case. And Myron Katz pointed out to me that, miraculously, he pointed out to me that my name is an acronym for 5 cultural groups that we sometimes refer to as races. I like to call us tribes. E is for European, L is for Latino, A is for Asian, N is for Native, and A is for African. And I describe it as a tree. This is the tree. These are the 5 branches, Elana. And that's the tree of humanity, all interconnected on one trunk. This is the Ilana tree. And I'm coming to you from Philadelphia, Pennsylvania, but I'm from New York, and I was just in New York earlier this morning, actually. So hi, Erica. Nice to meet you. And sorry we didn't see each other in New York when you were there, but maybe we'll meet in New Orleans.
Yes.
And hi, Dan Weiner. Nice to see you also, and congratulations and Mazel Tov on your anniversary, 33 years with Wisnia and Associates. And when I used to live in New Orleans, I lived in New Orleans from 1993 to 1997, best years of my life. And I wrote a paper when I left. Hi, Brandon. When I left New Orleans, I had to leave to go to graduate school, my first master's degree in conflict analysis and resolution. And I from school in Virginia, Fairfax, Virginia, actually. Who's in Virginia? David Stetz?
Yeah,
Yes.
was it GMU?
Yes,
Yeah, I used to live right across the street from GMU.
me too. Me too. 4400 Fairfax Drive or something like that. Anyway, 4300. That's what it was. Yeah, I used to live in Fairfax, and I did my conflict analysis and resolution degree at George Mason University, GMU. And I wrote a paper, I think it was like hypothetical, but it had something to do with Wisnia and Associates. It was like a hypothetical thing, but I think it was sort of loosely based on a project that you were doing that had to do with bringing building a housing project that was going to be like, there was a conflict resolution component that I was developing, hypothetically, to go along with building of a housing community. And what would it be like to, in the building of this new community, rather than just calling it housing project, a housing community, how would it be? And this kind of happened in the St. Thomas Irish Channel when that kind of dissolved, and it wasn't this sort of isolated housing project anymore, but it all got integrated and it became one whole community. And maybe my paper had something to do with that on some level. Also, so I was like developing this like process to elicit feedback from the community in the building of the building, in the building of the buildings. What would the people want? Would they want like a recreation center? Would they want like a basketball court? Would they want like a community meeting space? What would they want? And like, how could that be built into the whole how could a conflict resolution process and an elicited feedback dialogue process be built into the creation of the building, so the community that it was being built for with public money be really happy about what they were getting. And they could be involved.
Alana, let me interrupt you because we're almost out of time. I just want to say one thing.
Oh man, I got one more thing.
Okay, what's that?
There's a theater in New Orleans that, God willing, I like to buy. It's a Andy Galbiati told me about it, and he's interested in it, and we could do Unity Theater in New Orleans in a space, and we could build it out with solar panels and building science. It's an idea that
What's
I
the
hope
name
could
of it?
happen. I don't remember, and it's something, I don't remember exactly where it is, but maybe I'll
where
find
the
out for the next
Zeitgeist Theater was?
We'll say it again.
Is that where the Zeitgeist Theater was?
It's like the Shadow Box or something.
Zeitgeist sounds like it might be familiar. It's been in the newspaper.
I just want to, we're at 9 o'clock and I don't want to go past 9 o'clock. I just want to say one thing, which brings us back around. So when Make It Right was trying to find the right architect, they had these kind of community meetings you're talking about. And I was in a team that didn't get selected, but the team that got selected served fried chicken. And I think that's what won it for them.
Do you like fried chicken?
I know, but I'm just trying to point out that it wasn't the quality of the architecture. It was the quality of the chicken that won the competition. And
That's
unfortunately,
different.
that's not the right way to do it. I hope I do a little better than choosing what kind of chicken is accepted. Did you want
Well,
to say
that's
one thing?
important. People have to break bread together to really harmonize.
Maybe Brendan wants to say something.
Well, yeah. So speaking of fried chicken, one of my favorite festivals in New Orleans, and I think I was there for the very first one, the inaugural one. And ticket prices increase on September 23rd, but it's the National Fried Chicken Festival in New Orleans. It's usually down by the Riverwalk. It's October 4th and 5th. And it is always fun. They have multiple stages. If you've been to one New Orleans festival, you've been to them all. But this has people from Tennessee and Texas and New Orleans. It's all around the nation. It's the best fried chicken out there.
And everyone dresses up as different pieces of fried chicken.
I just want to say that.
Yeah. We will dress up
Waist to thighs.
respectable, I guess.
I hope that I met the goal of talking about the subject matter. I'm hoping that people will rewatch this and encourage members of
It
running.
was a beautiful PowerPoint presentation, Martin.
Well, thank you, but I'm hoping that I appreciate it. Don't misunderstand. But I'm hoping members of the city council running for city council will get a chance to watch this to see what solutions it provides, how to do a utility correctly or better, how to finance battery improvements. Those who are trying to finance battery improvements in New Orleans, we support them, but they want to use federal dollars and donations by contract by philanthropists. That's not going to get us to a large number of homes, most homes with microgrids, which is where we need to get to, I think. And so we're trying to show there's another way to do it. So hope I didn't cut anyone off from talking, and thank you for attending, everyone. Okay?
Here.
So good night.
Good night.
Thank you all.